Let us explore one-side infinite limits and vertical asymptotes. So there is always a relation between these two. And this example will help us to understand it better. Question is, determine the limit of function 1 over x minus 2 whole square as x approaches 2. Now if we need to find this limit, it's good to find limit from left side and from the right side. So what we can do is we can find limit of the function 1 over x minus 2 whole square as x approaches 2, let's say from the left side, so minus there, right? So that means what we can do is we can substitute a value of x which is not equal to 2 but very close to 2. So what we can do to calculate this limit is 1 over, instead of x I'll write 1.999 and then minus 2 whole square. Correct? So let's figure out what this value is. So it is 1 divided by, within brackets, 1.999 minus 2 bracket close square is equal to 1 million. So it is 1 million, a very large number. So this very large number we could write as infinity, right? So it is infinitely large. Well, infinity is a very large number, not a defined number, right? So basically the limit does not exist, but we know it is approaching a very high positive value. Now let's also figure out what is the limit of this function as x approaches 2 from the right side, that means 2 plus. So that means I'll put a value of x which is slightly more than 2. So in that case the value could be like 2.001, right? So that is slightly more than 2, and let's figure it out how much is this. So we'll again do the calculation. That is 1 divided by, within brackets, 2.001 minus 2 bracket close square equals to 1 million. So that is also a positive value, a very high value, so I'm writing infinitely large, right? So it's very clear from these two sets that the limit of this function 1 over x minus 2 whole square as x approaches 2 does not exist, right? Since it's going infinitely large, so it does not exist. So that is our answer, right? Now let's try to sketch and understand what this function may look like. So what we have here is at x equals to 2 we found that the function is approaching a very large value. So it's kind of like this. If we sketch this function, it will be kind of like this, right? Now here, let's say this is the value 2, right? So let me draw a vertical line at x equals to 2. So if you sketch this function, then it will look like kind of like this, right? So this point is, this line in fact is x equals to 2, right? This point is 2. Now that we can clearly see that the limit does not exist, right? What we note in this case is that if one side limit is infinitely large as x approaches 2, then x equals to 2 is a vertical asymptote. So what we notice here is that this leads to vertical asymptote. And the equation of vertical asymptote is x equals to 2. So that is kind of a very important result which we get from here, that if one side limit of a function is unboundedly large, infinite, positive or negative, in that case x equals to that value, the vertical line represented by x equals to that value is the vertical asymptote, right? So in this particular case we observed that the limit of the function as x approaches 2 was infinitely large when we approached the function from left side or right side. Therefore the line x equals to 2, the vertical line x equals to 2, is the vertical asymptote for the given function, right? So that is how one side limits, when they approach to infinity, they represent a vertical asymptote right? So that is how they are related. So whenever there is a vertical asymptote, contrary is always true, whenever there is a vertical asymptote at x equals to a, any general value x equals to a, then that implies that either left or right side limit of function approaching a should be infinitely large. It could be negative or positive, right? So that is what we understand, and that is what we can appreciate from this given example. I hope that's helpful. Thank you.